To those of you who are new or who have not yet been to any of my webinars, my name is Raquel Thompson, and I am a simple primary school teacher here at North Anglia International School, Hong Kong. I was previously head of maths and have developed a passion for this subject, and I just love, even though I'm now just teaching normal form, I cannot stop thinking about maths and investigating maths and trying to better and better my practice each time. Today we're going to be looking at maths language and how it matters. And I thought that we should start by talking about, obviously talking about language. I should point to, oh, hold on. I should pinpoint to you if my presentation cooperates with me. Yeah, I should point to you to a few kind of documents that I find very useful when I am planning, when I am not just planning, when I'm trying to get to grips with my subject knowledge and to really make sure that the children that I'm teaching get the best experience of maths, which includes the language that is used. One of them is the mathematics a glossary from the NCTM. It's fabulous. I'm going to actually, I don't know if you've used it before, but those of you who haven't, it looks like this, and it's PDF. You just search, say you want to look for factors. Oh, we must spell it properly first. And then it comes up on the side with just where the factor is, and then you can just use that, that definition to help you generate the resources and generate the questions that you want to lead the children into learning the actual concept of factors. So that's one that I really like. Another one that I received, it's a free resource that I received from Third Space Learning. It kind of has maths vocabulary and activities, some games and ideas. I'm not going to go through it, but it's got quite a lot of fun and good stuff in there. So I just wanted to point out, and another great resource, Improving Mathematics in Key Stages 2 and 3 by the Education Endowment Foundation. So just to start, so if you were wondering, you know, where will I go and find the language that I would like to use, appropriate language to use in my lessons. So those three documents would be, well, three of the places to go to. Let me go back to the presentation now. So I guess the first thing that when you're talking about language, it's not just about the words. Lots of times we put the keywords for each topic on displays, but it's also about questioning. And I feel like if you ask the right questions at the right time, the questions that lead to a good learning that leads to other questions, in fact, or that lead to good reasoning, then there's a better chance of getting of having better learning conversations with the children, and obviously better mathematical conversations happening. So one thing that lots of people use are the maths talk stems, and what they are kind of question starters that help the children with begin the discussion. So how does doing this to this number affect the other number, or what is another example of this? So it's some go-tos of questioning techniques that can help. And I know most of you know this, but it's actually, for me, I find it really useful to have sometimes to just look back at this and go, oh, let me try this question again, just to have it at the back of your mind, because we tend to use the same sort of go-to questions, and you'll see the ones I usually use in a minute. The other kind of key questions, so what do you notice? Why do you think that? Can you explain? Can you see it? Can you imagine it? Those questions are all there to elicit good learning, to elicit the use of the correct language to explain the mathematical reasoning. Some of my go-tos are my favorite ones: what's the same, what's different, and spot the mistake, which one is the odd one out, true or false, or always, sometimes, never, which they usually find very hard to understand. But those are my go-to ones. but the reason I was saying it's quite interesting to have the other one, the other maths STEM talk sentences or questionings just on the side. Sometimes it's good to vary, and that actually leads me very straight on to the main purpose of today's webinar, which is on language, but how we vary this language in a way that conduces to good learning, to progressive learning in maths. So hopefully you will have heard of the word variation. Most of you, I'm sure, if you're in the UK especially, will have heard many times. It's a maths word, which I think I came across when I around about 2018. And I found that it's quite a tricky concept to understand, not so much to understand, but actually to put into practice. So it's, you know, you can say, you can vary questions, and it's, you know, it's easy to understand that you have to make microscopic steps in order for the children to achieve a certain point. But it's hard to actually think about the questions that are those microscopic steps. So I thought that perhaps it would be a good idea to focus on this. I'm not going to say that I am the expert on variation. I am just very, very interested in this. I think it's very exciting when you get it right, and it's very exciting in the classroom when you see it happening properly. And by all means, I'm not the expert on it, and I'm still very much learning. So feel free to pitch in with some ideas later on if you have more experience on this. But I thought some people don't have much experience on this and have not heard so much. So I thought, as like an introductory sort of webinar, I could do this. I can do an introduction on variation, that's for sure. So it kind of is based on the Chinese models of teaching from Shanghai, and it's the central idea is that teaching with variation is to highlight the essential in order to then kind of go through the essential features of the concepts through varying the non-essentials. So by varying the non-essential features, you then come up with what is actually the concept that you're trying to achieve. Now, this is where it gets a little bit overwhelming sometimes. You think, oh, how does that work? So I'm going to go through an example that I have seen in a few webinars that I've attended or I have seen on YouTube as well, which I think are quite helpful to understand this concept of variation. So it's the elephant example, and I'd like you to imagine that someone had never seen an elephant, and how would you describe it to that person? You can, if you, I don't know how interactive you would like this webinar to be. I like it to be interactive. If you'd like to type on the chat what you would say makes an elephant. Some keywords that would describe an elephant. If no one writes anything, of course, I've got my own ideas here already. Well, usually, yes, large, gray, 4 feet large. So trunk, 4 legs, has a trunk, big ears, excellent. So it kind of goes with what I'm about to show you, that usually most people would come up with concepts such as it's gray, it's big, has tusks, has a trunk, and has big ears. So if you were to then show this picture to the children, you'd go, so does this match this concept that I've just described to you? And they would say, yes, of course. Okay, well, now I'm going to show you another picture. This picture here. And can you tell me, is this not an elephant? Well, it doesn't have tusks and it doesn't have big ears. So here is an opportunity that you have. It is an elephant, you know that it is, but it's the opportunity to tweak slightly the concept. So in this case, you would now say it can have tusks or not, and it can have big ears or not. But that's not so much the essential part of what an elephant is. But it still has, it's gray, it's big, and it's got a trunk. Okay, well, what about this one? This one is not big, but it's gray, it can have tusks, it can have big ears. And then again, you reassess this, the concept and what's essential and what is not essential. And you think, okay, well, it's not big now, but it could be big, it will be big when fully grown, because it's just a baby at the moment. So then you move on and you go, okay, well, why is this not an elephant then? And say, well, it's gray, but it doesn't have tusks. It doesn't have a trunk. It's got horns. It doesn't have big ears, really. Okay. And then you kind of, the discussion will be here, why is it, by using what they call a non-concept, then you become more aware and more clear as to what the actual concept is. And then once you've done this one, you go, okay, well, we're now then clear that an elephant is definitely gray. Sometimes it could be big when it can have tusks, it has a trunk, can have big ears. And then you might, and they go, yes, that's it. And then you introduce something to kind of throw them a little bit. And this is obviously a pictorial representation or a drawing of an elephant. And it is still an elephant because it has the key features of it, trunk being one of them, being large and so on. So hopefully this non-mathematical example has given you the motivation to continue today, first of all, and what's the word? Well, it will come back to me. It will give you the motivation to want to learn more and to want to really get variation into your classroom as much as possible. So we're going to start, variation can come in two forms. One is conceptual, the other one is procedural. We're going to start with conceptual, and the main idea is to draw the focus on, much like what we've just done with the elephant example, draw the focus on the similarities and differences between the examples so that the children can spot what is the essential feature, that is, what is the concept, and what is not essential and superfluous, I can't speak, superfluous. So kind of varying the representation will then highlight the essential features of the concept. So another thing that I've seen on a webinar, in fact, it was in this article. Every time I use someone else's resource or a good idea, at the top you will find where I've taken it from, and there's a link when I send you the PowerPoint as well, so that you can use it at another stage. So on here, there's an example where we're exploring the concept of a quarter, okay? So the first thing was to look at a standard way that the children would look at what's it called? A quarter. So what might they think is a quarter? And if you show this picture, what do you think children might say about the quarter? What do you think children might say? By what they can see in this particular picture. Okay, they might say, well, a quarter is a square because it's represented in a square. A quarter is pink. I could say that. Nothing to say that, no. And a quarter is a part. Yes, it is a part. And then I might show us a quarter in a non-standard way, which could be, what we mean with standard is the visual representation that the children are used to seeing, that we tend to show as, oh, that's what a quarter is. That all parts are equal. They look exactly the same. That's the standard visual representation. But a non-standard might look like this. Now, is this a quarter? Is this not a quarter? It's a less expected visual representation, but it's still a quarter, and it kind of challenges students to think deeply about what actually makes a quarter. And so in this case, they might tweak, like we did with the elephant, they might tweak their thinking, and they might tweak their concept of a quarter, and might think, oh, well, what is the same about them? Well, the same is that they have 4 parts. Of course, you can see 4 parts there. And this builds on the idea that a quarter is a part, and 1 part is a quarter, of course, and it's highlighted as well. They could be different colors. Well, I can see that they can be different colors, and that they could be different shapes as well. And that kind of takes away that misconception already that a quarter has to be a square, which if we had only represented a quarter like the first one in the standard option, then that's probably the idea that would stick in their heads. And then from the standard to the non-standard, we show a non-example, like the rhino that we just showed. So the non-example would have been something like this. And immediately they could see, okay, why is this a non-example? And you tell them, why is it a non-example? Well, it's clear they're not equal parts. So that even though these don't look the same, but they are equal in size, these are not equal parts. So this is a non-concept, non-example of a quarter, okay? Hopefully that makes sense. Now, I was thinking for this webinar how we could work together in terms of getting, like putting into practice some of the theory or some of the examples that I'm showing you here. So if we go to Miro board in a second, you will see task 1. I've put from that NCETM first document that I showed you, I took the definition for a rectangle, and what I want is for you to, using the, let me just show you what it looks like on my screen, bear with me, using the Miro board. Some of you will have been, oh yeah, some of you are there already. So using the Miro board, just draw any shapes that you think, what would you represent as a standard rectangle? How would you represent a non-standard rectangle? And what would you represent as a non-example? Just give about 5 minutes. There's shapes here on the side where you can use, that you can use, or you can just draw it yourself with the pen, sort of. We'll pretend that they're all straight lines. I think it's more fun if we have a go at doing these. So have a go. And let me know if I can help with anything, or if you're having any technical issues. So I guess at the moment, what I can see is that standard-wise, for the 2 examples that are there, people would have drawn a rectangle. That is the standard rectangle. And I can see some of you already drawing a square. Well, that is a great idea, because a square is a rectangle, but it's not, because we call it a square, or we tend to call it a square, it confuses children. They don't realize, why is it that a square is a rectangle? And that will allow for that conversation that a rectangle is kind of a parallelogram, but it has interior angles of 90 degrees, and that opposite sides are equal, and so on, okay? So kind of, oh, I forgot to put the definition here, that would have helped, but anyway. And your non-examples, obviously a parallelogram there, a triangle, that obviously kind of makes sense. I'll show you, thank you very much for that. We'll go back to the presentation now. Is that, here we go. So very much like you've done, I thought of the same, a rectangle as a standard representation, non-standard a square, and rhombus, it could be a compound shape, or a triangle, or any other shape really, that is not a rectangle. Just to draw out those non-concepts, those key facts that are essential to a rectangle, or those that are not essential to a rectangle. That doesn't make it, that does make sure that it's not a rectangle if they don't have it. Factors. Now, this was an example I just wanted to share with you. It was me playing with variation. I'm sure there's other ways of doing this, but this was a lesson that I was teaching in year 5. And what I wanted to do was to teach factors, first of all, and then at the end, I wanted them to find common factors between numbers. But my first idea, what I really wanted was for them to understand, the children to understand what the concept of factor. And from reading this particular definition and going through the White Rose Maths resources that we use a lot of, I came up with 3 kind of key concepts that I wanted them to come out, take from the lesson, from that particular lesson. Ignore the bit of finding common factors, that was extra. This was just to talk about the first learning objective. And so I didn't show them what I did was, so I came up with these. I knew this is what I wanted them. So I knew which questions to ask to lead them to get to it. And so what I did show them was something like this, where I covered the success criteria. So often we tend to show the success criteria, but I think it's much more powerful when they come up with the success criteria. But obviously we have to lead the discussion in order for them to come up with the correct success criteria. And so I showed them this and I said to them, only the blue equations, the statement, are representations, and representations are showing factors. Why are the others not? And so the idea was to show some standard, some non-standard, and some non-examples to elicit that conversation. What's different about them? What's the same? And so hopefully after a while we decided, okay, well, 1 times 15 does make 15 and 3 times 15 does make 15. But I'm saying that, and these are factors, they're showing factors here. And this is also showing factors. Well, kind of leading on the discussion, kind of bringing arrays back into the discussion, because children tend to forget. They tend to think, not forget, they tend to think that arrays are for the little children, but they're actually quite useful for key concepts such as this. So we talked about the standard, I showed them the standard and then showed them this example. Why is it that this one isn't showing factors? And that was to elicit the idea that factors come in pairs. 3 times 5 is in fact 15, and 1 times 15 is in fact 15. But 3 times 5 times 1, those 3 together, they're not factor pairs. They tend to come in pairs. And then the non-example as well. Oh, yes, a non-example, obviously the visual representation showing that there isn't an array there. So that's not showing factors or a product. It is still showing 15. If they counted the squares, they could still count 15. But they couldn't, there wasn't an array, you couldn't have that conversation of repeated addition that leads to multiplication and product. And also the conversation about the fact that a factor is not a decimal number, it has to be a whole number, which is why that was not one of the factor pairs that was there. So that was just one of my examples. Could I improve this? Absolutely. I've had since other ideas, but this is how I think all of us try in our classrooms. We trial and error, and sometimes we get it completely right, sometimes medium, and sometimes very wrong. But we learn from that, and I think that's the beauty of it. An example that I've seen from one of the Maths Hub's presentation I've seen online is this one, kind of having a look at all the aspects of the concept of a fraction. So the understanding that a fifth could be different sizes, and how do the children know which one is going to be longer, which paper tape is going to be longer? Well, looking at this one, looking at that one, this is 1/5 and I'm going to have 5 pieces. This is also 1/5 and I'm going to have 5 pieces. So I apologize, there's some weird something there that went wrong. So they would be able to visualize the concept and develop the depth of it as well. The next one is procedural, and procedural variation is all about the journey from A to B, and so kind of A being what you know already and B the learning and the new understanding. So you can do that by varying a problem or varying the processes, so using different methods, or varying the application, so like into similar problems. And it basically is how we proceed through the lesson, is how we scaffold the little steps throughout the lesson that lead to the big thing that we want them to, the big objective that we want them to learn. So with that in mind, in a fantastic book by Mike Askew, I don't know if you've read it before, but if you haven't, do get yourself a copy. It's got great ideas. He came up with these, and I wonder if you would like to have a look at this example and see if you can work out the answers to both sets on a piece of paper or wherever, and then let me know, as you do it, what do you notice? What's the same and what's different about the sets? Can you spot any patterns in either of the sets? And can you use what you've learned from one equation to another in any of the sets? If you have any, what I would like is really like, I would love to hear from you what you can see, what's your experience when you go through set A and set B, and what you think the children will experience by giving one or the other. And feel free to speak if it's quicker and easier, or just type on the chat. That would be great. We will do a little example together on Miro board again, based on this, but has anyone noticed anything yet? Same calculations in each set, though the order is different. So in set B, those grouped according to the numbers involved, which helps us to use the previous answers and our reasoning. That's exactly it, Louise. And I think that's what we should strive, what we should always aim for. Is it easy for us to come up with the actual questions? Not necessarily always, but that's what we should always try to do. You will notice that from 120 to 90, if you know the answer, excuse me, you will then see that, oh, there's two more and there's two more, so the answer has to be the same. And then 119, oh, it's just one less and just one less there, so the answer is the same. And then this one is not quite, this is not really much to do with the previous one, but it's similar, it's related to the next one, but the actual concept is the same. So I wonder if anyone could give me what could be the next question, what could be a question that could come up after 502, take away 367 on set B, whilst I read this. 522 take away 387. Yep, excellent. That would definitely extend. Anyone else? 492, so changing, definitely changing the hundreds, that provides an extra layer of extension of difficulty. Fantastic, okay. I think what we will do now, oh, thank you, Taz, 602 minus 467. So I think if we use Louise's and Taz's questions, perhaps Louise and Taz, Taz's would go after the 502 because it's more similar, and then 522, and then or not 522. They could either go. I would put out of those three perhaps the 492 as my last example to extend. So it's now your turn to play, as I always say. I find that, and what I would like. Oh, sorry, forgot to mention. This is something that comes up all the time. All these little tweaks, all these little variations that happen in these in the process of these questions, they provide opportunities for intelligent practice. And what they are is when you notice what Louise was saying earlier as well, when you notice that things are the same and what's different, and from that you can come up with a process that allows you to understand the concept better. Let me now show you what we are going to do on Miro board. So on this next one, I'd like us to start thinking about, I took one of the objectives, a simple objective, to use efficient mental strategies to add two numbers, for example, but ending up in what I want out of my lesson at the end, or my children to be able to do, might be that I want them to be able to do something such as 497 plus 138 quickly, mentally. Now, you know yourselves that a lot of children who are not trained or taught in this way will straight away get pen and paper and write down a formal method and do that formally, but how would we encourage the mental arithmetic skills in order for them to, well, the most efficient methods here would not be the formal one. And so if you could go back to the variation, to the mirror board, the middle board there, it's asking to use efficient mental strategies to add two numbers. So basically what I'm looking for is a set of questions that you would put in place. It's just to practice a little bit, set of questions, 4, 5, that would lead to 497 plus 138. What could we do that would lead to that? It would be great to see some of your suggestions here on the board. I think it's, or particularly I quite like it when I'm doing the maths. I think it makes it make more sense in my head. If you would prefer to just type on the chat, feel free, and I can easily type it for you on the mirror board as well. You don't have to use mirror board, you can use the chat function, either or. I think it'd be, in a normal workshop, we would all be discussing and there would be a buzz of ideas, but it's a bit harder on a webinar. So I can see some people are trying to put something in. So what would be our starting point, I guess? I know my ending point is 497 plus 138. How far back? No, that's okay, Leah. You can just type it on the chat. It's absolutely fine. The mirror board is just, I don't know, it's to make it more interactive. How far back in the skill do we want to take them to? Do we want to start with single digits? What age are we teaching? What type of children are we teaching? What age of children are we teaching? Do we want to go back to single digits and show that relationship with smaller numbers, or do we want to go straight into double digits or triple digits? If this is year 3, maybe we should start with adding hundreds to 3 digits. Yep, perhaps, yep. That sounds great. So they could do that definitely in their head, 500 plus 135. And then what would be the next step? Because I think what we need to have in our heads is what is the skill that we want them to use really in their heads in order to solve this. So we want them to adjust, don't we? We want them to realize that this is close to 500 and that by adding 3 to one side, I'm going to have to, well, actually I'm not going to say anything, because I think the beauty of having different smaller examples with smaller numbers is that it will give them the opportunity, especially, well, usually it's the other way around. You usually start with addition and you go to subtraction. But in this case, it's seeing whether the same method applies to addition as it did to subtraction. And they would find that it doesn't. In subtraction, whatever we took away, we added something to one side, we added to the other side. In addition, it's slightly different. If we add to one side, we need to take away from the other side, forming a 0 pair almost. Great, so 499. Ask children how they would round up to 500 first. Yep, absolutely. Okay. I'm going to type some ideas that I came up with. Doesn't mean that they are the best. I'm just going to type what I'm thinking in my head. So if we're really dealing with, you know, the younger folk, we can still start teaching them these strategies from a young age. So I could have introduced them before to this. So 9 plus 6 and 5 and 10 plus 5. What's the same? What's different? What do you notice? And then I could have, okay, what's 28 plus 7? oops, sorry, plus 7, which is 35. And then you could say, okay, well, let's try to use the same strategy, the same, apply the same process that we had up there. Okay, well, it's 28 is close to 30, so I think it's 30, but am I going to add 2 or am I going to take away 2? Well, then they realize, oh, actually I take away 2 from 7, so it's 5, and the answer is obviously going to be the same, and so on and so on. Then I agree, something like 199 plus 38, realizing that the 199 is close to 200. So obviously 237 would be, oops, the correct answer there. And I don't know what I've done there. and then perhaps, you know, then leading up, then at the end, obviously using these numbers that, I don't know who wrote them, but they're great numbers as well. They're great examples. And then at the end, you could put a non-example or an example with a mistake, like, I don't know, let's say 1,394 plus 68 equals 1,400 plus 70. What is the mistake? And they would have to realize what the problem was. Where did I go wrong? Where did my process fail? So are there any questions about this particular process? I think hopefully by doing and by discussing sort of, and by doing it either on the chat or on Miro, it has helped to understand the procedural variation. Let me go back to the now I've got another one which is also on Miro, but I'll show you here as well if you're not so keen on Miro. We could also aim to we could also vary by changing the problem. So varying sort of slight bits of the problem. So one thing stays the same always, and then one thing changes always slightly, but in a consistently in a way that is on purpose, of course. So if I had, for example, problem 1, there's 9 liters of apple juice and every 3 liters is put into a jar. How many jars are needed? That's quite an easy one to do. Then the next question might keep the 9 liters there and then ask, but what if it was 1 liter instead of 3? How many jars are needed now? Still something that I think most children would be able to access because we're talking about whole numbers, so not a problem at the moment. And then we throw in a decimal there. Okay, well, we have 9 liters, and then every 0.3 liters, which is 300 milliliters, is put in a jar. How many jars are needed? Now, this time is a bit tricky because how are they going to work out? What maths are they going to do? How are they going to work out how many jars are needed? Are they going to say that it's 3? Well, it can't be 3 jars because you needed 3 jars for the 3 liters. Are they going to say it's 0.3 jars? Or are they going to say it's 30 jars? How are they going to explain? So the conversation that comes from this example will really, will really help the children to consolidate the concept that you're trying to achieve. And actually the strategy that you want them to use when solving problems such as this one. And then you move on to 0.1, and it obviously is sort of the same. So hopefully having discussed how many jars, that there are 30 jars for 0.3 liter, that have 0.3 liters in each, hopefully they will then see a pattern, they will see a link, a connection, and then they will realize that for 0.1, that would be 90 jars. And the last one is bringing a different skill, realizing that 0.05 is a half of 0.10, so using our halves, but actually having, if I need a half of something, then I actually need to double. It's a very tricky concept, but it's something that should be built on. If you went straight from 9 liters to 0.05, how many 0.05 liters in 9 liters, or how many jars do I need? It would be completely alien to the majority of the children. But actually, if you take it little small steps to get there, it may still be alien to some, but I'm pretty sure that it will reach the majority of them by the end of the lesson. That's that from me. Where I was, when you look at variation, I always think, where do people start? When I look at variation, when I go to a webinar or I go to a workshop, I think, okay, this is great, but how do I start? What do I do? And it's complicated. We have very difficult, hard. Our schedules, daily schedules are hard. It's hard to find the time to really engage with making resources, unless you're very lucky and you just teach maths, in which case then you have more headspace for it. But the general teacher, primary teacher especially, doesn't really have the time to produce resources from scratch as such. So I was trying to find some examples that are out there that could serve as a basis or inspiration, or just a place to start for some ideas on variation structure. We have access here to premium resources. They are paid resources, but they kind of look like this. This is one example. And you can see how this is an example of a worksheet that is used for in Year 5 for improper to mixed numbers. And you can see the differences, the slight differences each time. So in the first question, you are given the pictorial representation and the fraction, and you are asked to write as a mixed number. And then the next one, it's still the pictorial representation, but this time I have to count how many, what the numerator is, and then turn it to a mixed number. And then the next one, there's nothing there, and the next one as well. And then following on from that, then I now have to do the opposite, the inverse. I have to color it in, show that I know how to show 7/3 here, or 8/3, and so on. And then moving on along on the back page, you look at converting improper fractions. And on this side, you have just, if you notice, the numerators are all 10s. That makes it a bit easier. That is also allows the children to have a conversation, or to really start thinking about how big 10 halves or 10/3 or 10 quarters and 10/5 are. But then on the next 4 questions include different numerators and different denominators. So are these perfect resources? I mean, nothing really is perfect, of course, because we always should adapt our resources to the class that we have. But I think they are a good place to start, to take inspiration, to adapt. And if you can get your hands on some of these, it's one thing that we have been using that has helped us to develop our own resources. Another example, for example, in terms of reflection. So you will notice that the reflection, the mirror line, is right next to the shape here. And we start with simple shapes. Then we start with more complex shapes, a compound there, and then a triangle with no right angles, and then a trapezium. And then on here, the mirror line gets shifted away from the shape, and it becomes harder and harder each time. And then they have to find some, spot the mistakes, then clear even harder objects to reflect, and then moving on to coordinates and so on. Now, this is just one time, well, there are 2 tiny examples of what's out there. If you want to find out more about variation, I definitely would suggest exploring the documents that I will send with the email at the end, well, tomorrow, once I have the video of this webinar. Also, the NCTM's 5 big ideas. There's a set of 5, I think it was 5 webinars. This one is in particular is about variation. I took a lot of inspiration from it, and it's great, really great. It's a conversation between NCTM leaders. It's really, really great. So I would definitely suggest, recommend that you listen to it. It's quite long, but if you have the time one day. Mr. Barton Maths podcast with Anne Watson and John Mason, also a great, great listening podcast. Well, the article that I've used for some of the examples that I've used in the presentation today. Great article to read as well. And then there's a really good PowerPoint made by the Maths Hub Archimedes in Northeast, which I've taken some inspiration as well from. So I think I find that trying to get across this completely in less than an hour or in an hour, what variation is from afar without being able to practice is a bit difficult. But I hope I've given you inspiration to want to find out more and to want to explore more in your classrooms. There's some bibliography there if you would like to actually read on. And now it's time for questions if you have any. And that is that from me today. Any questions or any suggestions or any feedback, please feel free to, it would be lovely. I really would love to have feedback. I feel like today I haven't been the most eloquent. I feel a full day of teaching behind me, but hopefully enough to excite you about variation. And Simon and Louise, if you could send me a private message, I think you can do that on this chat with your emails. I will make sure that I'll send you the videos from the first session, if I'm not mistaken. Oh, thank you, Lilia. I didn't feel like it today. Okay, Louise, let me write this down before I lose you. Okay, Louise, I've got yours. And Simon, if you want to give me your address as well, I'll make sure I'll send. Obviously, the video of this will be sent at some point at the end of this week. It needs to be edited, and but it will come, hopefully. And if you don't get it, I might type here. This is my email address. Let me just put it here for everybody. If you have any questions or any problems, you don't receive anything, feel free to email me directly. I'm pretty efficient with responding. Okay, so underscore. I'm trying to take note of all your emails. And Simon, I've got yours, thank you. Okay, I think I've got everybody who needed it. Thank you so much, everybody. It's really kind of you to join from different parts of the world, I think. And I will hopefully see you in the next one, which will be in January at some point.